Today we are going to study about motion in plane and projectile motion. We have already studied about rest in motion. We have studied about vectors. We have studied about motion under gravity. We have studied about average speed, average velocity, instantaneous velocity. We have studied about all these things in the past. Now we are going to study about motion in a plane and projectile motion. Now motion in a plane. Now when we are saying about motion in plane, we have two-dimensional motion. What is it? Two-dimensional motions. Two-dimensional motions. So, but before that, we need to understand what is a position vector and what is a displacement vector. So let's study about position vector. We're going to study about position vector. Now, what exactly is position vector? A vector that extends from a reference point to the point at which the particle is located is called as a position vector. For example, let R be the position vector of a particle P. Let's say I'm starting from here, from say this is O, this is P, okay, and this is O. From here to here, it is going in this direction. So let's say this R be the position vector. This is R. Vector R is the position vector to a particle P located in a plane with reference to the origin O. Now this is the origin O in an XY plane. Say I'm drawing XY plane over here. So it's starting from here. So this is your x-axis and this is your y-axis. Now position vector R is equal to xi plus yj. I told you what is xi. This is xi. We have studied this in the past. And this is yj. So R is equal to position vector R. So is equal to xi plus yj. That is how you take, right? If there is yj, then there is also yj. If there is xi, then there is also xi. So you can say yj plus xi. That is your position vector R. Okay. Now direction of the position vector, if in case it will have to take the direction of the position vector. Let me just check how can I erase this. Okay, so now we're going to study about the direction of the position vector. Direction of a position vector R is given by an angle theta. Let's say, let's say the angle is theta. Okay. So the direction with x-axis, the direction of position vector R is given by angle theta with x-axis is tan theta is equal to y by x. So if you remember when I was telling you about trigonometry, theta would become tan inverse y by x, right? Tan inverse y by x. Okay. Now, in 3 dimensions, the position vector is represented by R is equal to xi plus yj plus zk. Xi plus yj plus zk. You always have a cap because it's a vector. So, in 3 dimension, it is always represented by R is equal to xi plus yj plus zk. Alright. Now, let's do what is displacement vector. Now what is displacement vector? Let me just write down the heading as displacement vector. Now displacement vector is a particle moving in xy plane with a uniform velocity v and point O as an origin for measuring time and position of the particle. So if the particle be at position A, let's say the particle is at position A. So first of all, let me just draw the xy plane. All right. So the particle is moving from here to here. So this is A. All right. And from here it is actually moving to B. All right. And so what did I say? It is moving from point A to point B in T1 and T2 time. Say T1 and T2 time. Okay. So let's say this one is a position vector R. Say I'm calling it as R1. Okay. And from here to here, from the origin to point B, say this is position vector R2. Now from here to here, there is a change in the position, right? So I'm calling this